When the Orion capsule hits the Earth's atmosphere at 40,000 kilometers per hour, the air in front cannot get out of the way fast enough. It compresses and superheats, ionizing into a glowing, hyperdense plasma sheath. That plasma acts as an impenetrable physical barrier to radio waves. For 4 agonizing minutes, all telemetry will sever, and the capsule will plunge into a total communications blackout. This will be the reality for the 4 astronauts of the Artemis II crew. Returning from roughly 46,000 kilometers past the moon, they will be traveling faster than any human being has ever flown. During this window of absolute silence, the exterior of their capsule will reach temperatures passing 2,760 degrees Celsius. There is no abort sequence to trigger, and no backup plan if the vehicle begins to fail. Getting a crew to the moon is a massive problem of propulsion. Getting them home is a terrifying problem of survival, dependent entirely on one specific piece of engineering holding together in the dark. To protect Orion, NASA built an enormous heat shield out of Avcoat. This is the exact same material formulation that successfully brought every single Apollo crew home from the moon. Avcoat works as an ablative shield, meaning it is designed to deliberately destroy itself. As the extreme heat hits the surface, the top layer chars, absorbs the thermal energy, and then cleanly erodes off into the slipstream. Because of that Apollo legacy, engineers were highly confident, and when the uncrewed Artemis I test flight splashed down in 2022, it initially looked like a flawless triumph. Then the post-flight inspection data came back. Across more than 100 locations, the Avcoat had failed to ablate evenly. Instead, it had cracked and ripped away in deep, irregular chunks. An ablative shield with jagged, unpredictable material loss is essentially a parachute with random holes in it. It will likely slow you down, but you cannot mathematically guarantee it will protect a human crew on the next flight. The damage correlated to a skip re-entry. The capsule dove into the atmosphere, bounced back out, and took a final plunge. During the skip, the outer shield cooled into an impermeable crust. Trapped internal gases built immense pressure, until plunging back, they violently ruptured. Tearing off the compromised heat shield and replacing it would add years of delays to an already slipping timeline. So NASA made a hard choice. They will fly Artemis II with the already bonded shield. To protect this compromised shield from fracturing again, NASA is choosing to rewrite the flight path for the journey home. The new solution eliminates the skip entirely. Orion will fly a steeper, continuous direct descent. No bounce, no pause. The physical trade-off is clear. The crew will endure significantly higher structural G-forces and an intense, uninterrupted spike in peak heating. Re-entry accidents have claimed 7 lives, proving a single failure in thermal protection can turn a routine return into a fatal structural breakdown. NASA's latest simulations show the cabin module survives, even if the shield loses far more material than it did on Artemis I. However, internal modeling still places overall mission risk between 1 in 50 and 1 in 2. A statistical coin flip, the crew accepted anyway. Around April 10, 2026, the crew will discard their service module. The remaining pod, roughly the size of an SUV, will rotate its flat base forward, completely exposing the Avcoat to the incoming atmosphere. Within 90 seconds, the temperature will cross 2,000 degrees Celsius. The plasma will close over the capsule like a fist, and exactly as physics dictates, the radio will die. In Houston, flight controllers will stare at blank screens. For roughly 4 minutes, they won't receive a single packet of data. They will just wait, trusting that the modified angle of attack is keeping the shield intact. Assuming the structure holds, the capsule will bleed off enough speed for the sequence of drogue and main parachutes to deploy, slowing the vehicle to a manageable 27 kilometers per hour before a Pacific splashdown. Artemis II is the final gatekeeper for the program. Success here validates the ride home for the first human lunar landing in 50 years. A failure during these 4 minutes stops everything we plan to build beyond Earth orbit.